Right, in this video, we're going to talk about suggested homework exercises from 2.4, and we'll be talking about the chain rule. The chain rule is going to be used to help us differentiate compositions of functions. So we're going to first figure out decomposing these compositions to figure out what's inner and what's outer, and what is it that we need to do to apply the general power rule here, or the general product or quotient rule, or something like that. So usually it's going to be the general power rule here. So first, let's identify my inner function here. So u in number 3, my u is going to be equal to, the inner function is 6x minus 5, and I want to write y as a function of u, so that's this box over here. So that's going to be u to the 4th. That's all they want me to do. They don't want me to actually do any differentiation yet. Just, can I write y as a function of u? Number 5 is u is going to be the inner function here, and I probably want this to be the denominator of 3x plus 5, and y will be 1 over u, or u to the negative 1st, so I can differentiate that with the simple power, or with the power rule, would be the general power rule. Number 7, we have our inner function will be cosecant of x, because this is to the 3rd power on the outside of that. So my y is going to be u to the 3rd. Let's look now at number 9 and actually apply this to help us find some derivatives. So with number 9, y is equal to 2x minus 7 raised to the 3rd. So I'm going to make a u substitution, that u is my inner function of 2x minus 7. My u prime is going to be 2, and y is going to be u to the 3rd. My y prime will be the derivative of this function with respect to u times the derivative of u with respect to x, which we denote as u prime. So y prime is 3, replace the u with what it is, squared times u prime is 2. U prime is the derivative of the inner function. 3 times 2 is 6. We have 2x minus 7 raised to the 2nd. Let's go ahead now and look at number 11. G of x is equal to 3 times 4 minus 9x to the 5/6 power. I'm going to make a u substitution, that u is equal to 4 minus 9x. U prime is going to be negative 9. So g of x is going to be 3 u to the 5/6 power. G prime of x is going to be 3 times 5 is 15 over 6, u to the 5/6 minus 1 times u prime. G prime of x is 3 goes into 15 5 times, 3 goes into 6 2 times, u to the 5 6 minus 1, which is 6 6, so 5 minus 6 is a negative 1 6 times u prime is a negative 9. G prime of x is negative 9 times 5 is negative 45 over 2. U to the 1/6 in the denominator. G prime of x is a negative 45 in the numerator. 2 times, and then my u is 4 minus 9x as my inner function in the denominator raised to the 1/6 power. Let's look at number 13. Thirteen says h of s is equal to a negative 2 times the square root of 5s squared plus 3. That is the same thing as h of s is equal to a negative 2 times the quantity 5s squared plus 3 raised to the 1/2 power. So I see my inner function u is 5s squared plus 3, and my u prime will be 10s. H of s is a negative 2 u to the 1/2 power. H prime of s will be a negative 1. Half of negative 2 is negative 1. U to the 1/2 minus 1 will be negative 1/2 times u prime. H prime of s is a negative u prime over u to the 1/2 power, a negative 10s over the square root of 5s squared plus 3. All right, let's look now at number 15. Says y equals the cube root of 6x squared plus 1, means y is quantity 6x squared plus 1 raised to the 1/3 power. U is 6x squared plus 1. U prime is 12x. Y prime, or y is u to the 1/3 power. So y prime is 1/3 u to the negative 2/3 power times u prime. Y prime is u prime over 3 u to the 2/3 power is 12x over 3 times u is 6x squared plus 1, 2/3 power in the denominator. It's 1, and that's 4. Y prime is 4x over 6x squared plus 1 to the 2/3 power. Let's rationalize that denominator. 6x squared plus 1 to the 1/3. 6x squared plus 1 to the 1/3 is y prime is 4x cube root of 6x squared plus 1 over 6x squared plus 1. Let's look at number 17. Seventeen is y equals 1 over x minus 2, with u being my denominator of x minus 2. Y is equal to 1 over u, or u to the negative first power. U prime is 1. Y prime is negative u to the negative second times u prime. So y prime is negative u prime over u squared, be a negative 1 over x minus 2 quantity squared. Let's look now at number 19. Nineteen says g of s is equal to 6 over quantity s squared minus 2 raised to the third power. So inner function u is s squared minus 2. U prime is 2s. G of s can be written as 6 over u to the third, or g of s can be written as 6u to the negative third power. G prime of s will be a negative 18 u to the negative fourth times u prime. G prime of s will be a negative 18 u prime over u to the fourth power. So that will be negative 18 times 2s over s squared minus 2 raised to the fourth. G prime of s will be a negative 36s over s squared minus 2 raised to the fourth power. Let's look now at number 21. 21 is y equals 1 over the square root of 3x plus 5. U will be my inner function of 3x plus 5. Going to rewrite this as 3x plus 5 to the 1/2 power, which is the same thing as 3x plus 5 all raised to the negative 1/2 power. U prime is going to be 3. Y is going to be u to the negative 1/2 power. So y prime will be a negative 1/2 u to the negative 3/2 times u prime. Y prime will be a negative u prime over 2u to the 3/2 power. That will be equal to a negative 3 over 2 u to the 3/2, with u being 3x plus 5. Let's go ahead and rationalize that denominator by multiplying by 3x plus 5 to the 1/2 in the top and 3x plus 5 to the 1/2 in the bottom. So y prime is a negative 3 square root of 3x plus 5 over 2 times 3x plus 5 to the 4/2 will be squared. That makes a rational exponent in the denominator. Let's look at number 23. 23 is f of x is x squared times x minus 2 raised to the 7th power. And we have a product rule here. So let me not write it out with u's and v's. Let me see if I can just differentiate the first part, leaving the second part alone, plus leave the first part alone, and I want to differentiate this second part now. We'll talk about that. So my inner function u here is x minus 2, and my u prime is going to be 1. So I'm going to write this f prime of x is 2x times x minus 2 to the 7th plus x squared times the derivative with respect to x of u to the 7th. So I've done a u substitution there. I'm going to use my general power rule with my chain rule. F prime of x is 2x x minus 2 to the 7th plus x squared times 7u to the 6th times u prime. So f prime of x is 2x x minus 2 to the 7th plus x 7x squared times u is x minus 2 raised to the 6th times 1, which doesn't do anything for me. I see f prime of x equal to, I have a common factor of x times x minus 2 to the 6th. And that will give me 2 times x minus 2 plus 7x f prime of x is x times x minus 2 to the 6th times 2x minus 4 plus 7x. F prime of x is x times x minus 2 to the 6th times 7 plus 2 is 9, x minus 4. Let's look now at number 25. 25 says f of x is equal to x, sorry, this is y equals x root 1 minus x squared. So I have u is 1 minus x squared, u prime is a negative 2x, y is equal to x times u to the 1/2. So y prime is derivative of the first part, leave the second part alone, plus derivative of the second part, leaving the first part alone. And don't forget to multiply by the derivative of u because of the general power rule. So y prime is going to be u to the 1/2. So that's root 1 minus x squared plus x times a negative 2x. These are my things that are in my numerator. My denominator is 2 and the square root of 1 minus x squared. See if we can cancel anything, 2 and 2, making this a negative x squared over root 1 minus x squared. Let's make a common denominator here, 1 minus x squared over root 1 minus x squared. Y prime is 1 minus 2 x squared over root 1 minus x squared. And I'm not going to try to rationalize the denominator this time. There's really no point to that. So let's go ahead and look at number 27. Y equals x over root x squared plus 1. So we're going to have a composition of functions here for my v term. I call this u over v. U is x and v is x squared plus 1 to the 1/2. So u prime is 1, v prime is 1/2 x squared plus 1 to the negative 1/2 times the derivative of the inside is 2x. So 1/2 of 2 will become 1, making my v prime equal to x over square root of x squared plus 1. So y prime is u prime v minus v prime u all over v squared. Y prime is 1 times that, so that's x squared plus 1 to the 1/2 minus v prime times u is x squared plus 1 to the negative 1/2 over v squared will be x squared plus 1. And I'm going to factor here that my GCF is going to be x squared plus 1 to the negative 1/2. That will leave me with x squared plus 1 to the first minus x squared over x squared plus 1 to the first. This will come down with this one. 1 and another half is x squared plus 1 to the 3/2 power. X squared minus x squared will zero each other out. And that will leave me with 1 in the numerator. So again, I don't see a need to rationalize here, but I could write this as this or as this for my final answer. I like this form better. If you, for some reason, want to rationalize that, would turn into that. All right, let's go ahead and look at number 29. B g of x is equal to x plus 5 over x squared plus 2, 1d squared. So I have a couple different ways that I can look at this. I can just square everything and then have composition of functions for u, composition of functions for v in my quotient rule, or I can use my power rule first, since it's the outermost function, and then do my quotient rule. That's what I'm going to do. So I'm going to say g of x is equal to u squared, where u is equal to x plus 5 over x squared plus 2. My u prime is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So my u prime will be x squared plus 2 minus 2x squared minus 10x over x squared plus 2 quantity squared. My u prime is x squared minus 2x squared is negative x squared minus 10x plus 2 over x squared plus 2 quantity squared. So g prime of x is 2u times u prime. G prime of x is 2 times u plus 5 over x squared plus 2 times that stuff. I need to give myself more space here. G prime of x is 2 times x plus 5 over x squared plus 2 times a negative x squared minus 10x plus 2 over x squared plus 2 quantity squared. So we have g prime of x is 2 times x plus 5. I'm going to factor a negative 1 out and make this x squared plus 10x minus 2. I don't think that factors into anything. And then this is going to be x squared plus 2 to the 1, 2, and another one is 3. All right. Let's look now at the next problem, which will be 35. And we're going to use this chain rule with trig functions now. So 35 says y is equal to cosine of 4x. So my inner function u is 4x. U prime is 4. Y will be cosine of u. So y prime will be a negative sine of u times u prime. Y prime will be a negative sine of 4x times 4. Y prime will be a negative 4 sine of 4x. So now at number 37. 37 says g of x is equal to 5 tangent of 3x. So my inner function, u, will be 3x. U prime will be 3. G of x will be 5 tangent of u. G prime of x is equal to 5 secant squared u times u prime. G prime of x is 5 secant squared of 3x times 3. So g prime of x is 15 secant squared of 3x. Let's look now at number 39. Number 39 says y is equal to sine of, I'm going to put a bracket here to be clear. This is pi x squared inside of sine. So I would like to simplify this down into y equals sine of pi squared x squared, just to eliminate a function from this. And my u is going to be pi squared x squared. My u prime is going to be 2 pi squared x. Y is equal to sine of u. Y prime is cosine of u times u prime. So y prime is cosine of pi squared x squared, which is pi x squared, times my u prime is 2 pi squared x. So y prime is 2 pi squared x cosine of pi x quantity squared. Let's look now at number 41. Forty-one says h of x is equal to sine of 2x cosine of 2x. I'm going to simplify this quite a bit here. That remember sine of 2 theta is equal to 2 sine theta cosine theta. So if my theta here is 2x, I can say h of x is equal to 1/2 times 2 sine of 2x cosine of 2x. Say h of x is equal to 1/2 sine of 2 times 2 is 4x. My u is equal to 4x, and my u prime is equal to 4. So h of x is going to be 1/2 sine of u. H prime of x is going to be 1/2 cosine of u times u prime. H prime of x is 1/2 cosine of 4x times 4. Half of 4 is 2. Cosine of 4x. Let's look now at number 43. Forty-three says f of x is equal to cotangent of x over sine of x. I can bring the sine up as a cosecant and do a product rule instead of a quotient rule. It really it doesn't matter. I want to try and leave it as much as I can here, like this. So let's call this u over v, where u is equal to cotangent x v is sine x, u prime is a negative cosecant squared x, v prime is cosine of x. So we want u prime times v, so f prime of x is u prime v minus v prime u all over v squared. F prime of x is cosecant and sine are reciprocals of one another, so that's going to leave me with a negative cosecant x. And minus, this is going to be, let's call this 1 over sine x here. And let's call this cosine squared x over sine x here, and all over v squared. So that's sine squared x. So f prime of x is going to be take that divided by sine out, that negative divided by sine out, and put the negative out front, and put the other sine down here, call that sine cubed. This will be 1 plus cosine squared. So I'm going to call that f prime of x is a negative cosecant cubed, and then that's going to be minus a cosecant times cotangent squared. I think I can simplify that some, but there's really not a lot of point in doing that right now. This is good enough for an answer. Just if I pulled out that negative cosecant, I might get, I'm not going to get a 1 plus cotangent squared, so I'll just leave it just like that. So let's look at number 45 now. 45 is y equals 4 secant squared x. So u is secant x, u prime is secant x tangent x. Y equals 4u squared. Y prime equals 8u times u prime. Y prime equals 8 secant x times secant x tangent x. So y prime equals 8 secant squared x tangent x. Let's look at number 47. Says f of theta is equal to 1/4 sine squared 2 theta. So this is f of theta equals 1/4 of sine 2 theta squared. So my u is equal to sine 2 theta, where I have an inner function there as well. My u prime is going to be 2 cosine of 2 theta. Derivative of sine is cosine, derivative of 2 theta is 2. So f of theta is 1/2 u squared. F prime of theta is u times u prime. F prime of theta is sine 2 theta times 2 cosine 2 theta. F prime of theta is 2 sine 2 theta cosine 2 theta, which makes this sine 4 theta. Let's move on down to number 63. We need to find the slope of the graph at the given point. So y is equal to square root x squared plus 8x, and we're at the point 1, 3. So y is equal to x squared plus 8x to the 1/2 power. U is x squared plus 8x. U prime is 2x plus 8. Y is equal to u to the 1/2 power. Y prime is 1/2 u to the negative 1/2 times u prime. Y prime is u prime over 2u to the 1/2. It's equal to 2x plus 8 over 2 times the square root of x squared plus 8x. I see a 2 in the top that can cancel out with the 2 in the bottom. So y prime is x plus 4 over root x squared plus 8x. I need to evaluate that. 1x is 1. 1 plus 4 over root 1 squared plus 8 times 1 is 5 over root 1 plus 8 is 5 over root 9 is 5/3 for my slope. And I have my point, so I can find that's just the slope that I want, so that's fine. It didn't ask me to find the equation of the tangent line, so I'll stop there for 63. Let's look at number 65. F of x is equal to 5 times x cubed minus 2 to the negative 1st power with the point -2, -1/2. So u is x cubed minus 2. U prime is 3x squared. F of x is 5u to the negative 1st. F prime of x is a -5u to the negative 2nd times u prime. So f prime of x is -5 times u prime is 3x squared over this to the 2nd. U is x cubed minus 2. Let's go ahead and evaluate this at -2. This will be a -15x squared over x cubed minus 2 squared. So -15 times -2 to the 2nd over -2 to the 3rd minus 2, and all that squared is -15 times 4 over -8 minus 2 squared. F of -2 is a -60 over -10 to the 2nd, be a -60 over 100 is -6 over 10 is -3/5. Let's look at number 67 now. 67 says y equals 4 over x plus 2 quantity squared. The point given to us is 0, 1. So let's say y equals 4 times x plus 2 to the negative second. U is equal to x plus 2, and u prime is equal to 1, making y equal to 4u to the negative second. Y prime will be a negative 8u to the negative third times u prime, or y prime is equal to negative 8u prime over u to the third, negative 8 times 1 over x plus 2 to the third, so negative 8 over x plus 2 to the third. Y prime at 0 is negative 8 over 0 plus 2 to the third. Negative 8 over 2 to the third is negative 8 over 8 is a negative 1. Scroll on down now to 79. Find the equation of the tangent line to the graph at the given point. So we have f of x is equal to root 25 minus x squared. We're given the point 3, 4, and we want the equation of the tangent line now. So f of x is 25 minus x squared to the 1/2 power. U is 25 minus x squared. U prime is a negative 2x. F of x is u to the 1/2. F prime of x is 1/2 u to the negative 1/2 times u prime. F prime of x is u prime over 2 u to the 1/2 is negative 2x over 2 times the square root of 25 minus x squared. 2's will cancel. F prime of x is equal to a negative x over root 25 minus x squared. F prime at 3 will be a negative 3 over root 25 minus 3 squared. So negative 3 over root 25 minus 9 is a negative 3 over root 16. So negative 3 over 4. So y minus y1 is equal to m times x minus x1. Y minus 4 equals negative 3/4 x plus 9/4. Y equals negative 3/4 x plus 9/4 plus 4 over 1, which I need to multiply by 4 over 4 to make a common denominator. Y equals negative 3/4 x plus 9 plus 16 is 25 over 4. Let's look now at number 81. Only concerned on the open interval 0 to 2 pi. For this graph, f of x is equal to 2 cosine of x plus sine of 2x. So I'm going to rewrite as 2 cosine of x plus 2 sine x cosine of x. I'm going to factor 2 cosine of x times 1 plus sine of x. It's probably not the way that they want me to solve this if they wanted me to use the chain rule, but you can use your identities and simplify there. So f of x is equal to u times v, where u is equal to 2 cosine of x, and v is equal to 1 plus sine of x. U prime is a negative 2 sine x. V prime is cosine of x. So f prime of x is u prime v plus v prime u. F prime of x is a negative 2 sine x times 1 plus sine x plus cosine of x times 2 cosine of x. F prime of x is negative 2 sine x minus 2 sine squared x plus 2 cosine squared x. This is f prime of x is a negative 2 sine x plus 2 times cosine squared x minus sine squared x. Cosine squared minus sine squared is cosine 2x. F prime of x is a negative 2 sine of x plus 2 cosine of 2x. Now, was that the most efficient way? It was not. I just wanted to show you this is the way that you can do it with avoiding the chain rule. But let's go back and use the chain rule and show you that we can do this better with the chain rule. So that was, and I haven't solved it yet, but I'll go back and solve it in just a second. Let me go back and restart 81 here, which is f of x is equal to 2 cosine x plus sine of 2x. So f of x is equal to 2 cosine of x plus sine of u, where u is 2x and u prime is 2. So f prime of x is a negative 2 sine x plus cosine of u times u prime. F prime of x is a negative 2 sine x plus 2 cosine 2x, which is exactly what we just had with all those identities and everything that I was doing just a minute ago. So we want to find where this is equal to 0. So now I'm going to want to think about an identity for cosine 2x that only has sines in it. Let me get rid of these 2's first, though. This is going to be cosine of 2x minus sine x is going to be 0. So we already said that cosine of 2x is equal to cosine squared x minus sine squared x, right? So it's also equal to 2 cosine squared x minus 1. It's also equal to 1 minus 2 sine squared x. Since I see a sine in the problem, I want to go with this version, this third version, 1 minus 2 sine squared x, that has sines in it. So 1 minus 2 sine squared x minus sine x equals 0. Let's multiply through by negative 1, 2 sine squared x plus sine x minus 1 equals 0. So are there factors of negative 2 that add up to be 1? Absolutely. So 2 sine x, this is plus 1 minus 1, this is sine x. So 2 minus 1 is 1, that's 2 sine squared, and that's a negative 1. this equals 0. So 2 sine x minus 1 equals 0, or sine x plus 1 equals 0. 2 sine x equals 1, sine x equals 1/2, or sine x equals -1. Time to remember your unit circle, where on the unit circle is between 0 and 2 pi, not included, is sine 1/2. Well, x is pi over 6, and it will also be at 5 pi over 6. And then where is sine -1? That will be at 3 pi over 2. So my answers here are pi over 6, 5 pi over 6, and 3 pi over 2. All right. Those are x values. We should go back and we should turn those into ordered pairs. So f of pi over 6 is 2 cosine of pi over 6 plus sine of 2 times pi over 6 will be cosine of pi over 6 is √3 over 2, plus sine of pi over 3 is also √3 over 2. So that is 2 plus 1 is 3 √3 over 2, giving me a point here of pi over 6, 3 √3 over 2 for one of my horizontal tangents. We have f of 5 pi over 6 will be 2 cosine of 5 pi over 6 plus sine of 2 times 5 pi over 6. So that will be 2 times, and then the cosine will be negative √3 over 2 plus, and then 5 pi over 3 is a negative √3 over 2. So that's going to be a -2 minus 1 is a -3 √3 over 2, giving me an ordered pair here of 5 pi over 6, -3 √3 over 2 for a point of horizontal tangency. And my last one was f of 3 pi over 2 is 2 cosine of 3 pi over 2 plus sine of 2 times 3 pi over 2. So that is cosine of 3 pi over 2 is 0. Sine of 3 pi is also 0. 0. So that gives me a point of 3 pi over 2, 0 for a horizontal tangent. Let's see. All right, on to number 83. Just a couple more problems here. I know this is a little long. F of x is 5 times 2 minus 7x raised to the 4th. Let's find the second derivative here, starting with u equals 2 minus 7x. U prime is equal to -7. F of x is 5u to the 4th. f prime of x is 20 u to the third times u prime. So f prime of x is 20 times 2 minus 7x to the third times -7. So that'll be f prime of x is -140, 2 minus 7x raised to the third. Now we have u is also 2 minus 7x, and u prime is going to be -7 again. F prime of x is a -140 u to the third. So f double prime of x is going to be -420 u to the second times u prime. So f double prime of x is -420, 2 minus 7x squared times -7. Give me 0, 14, 2, 9, 2 minus 7x 1d squared for my second derivative. Let's look now at number 87. F of x is sine of x squared. So u is x squared, u prime is 2x, f of x is sine of u, f prime of x is cosine of u times u prime. F prime of x is 2x cosine of x squared. I have a product rule involved here. So f double prime of x will be it's 2x, and v is cosine of x squared. Prime is 2. V prime is negative sine of x squared times 2x. Give myself more space to see that. U is 2x. V is cosine of x squared. U prime is 2. V prime is negative sine of x squared times 2x. So f double prime of x, which is u times v here, is u prime v plus v prime u. F double prime is 2 cosine x squared plus 2x, and 2x is 4x squared, and that's negative sine of x squared. That was 87. That's our last one for this video, so we'll come back next time and we will talk about suggested homework problems from 2.5. See you for the next video.